Video, we are going to learn about the normal distribution as an approximation to the binomial distribution. At the end of this video, you should be able to use normal distribution to approximate the binomial distribution. So, we can use normal distribution as an approximation to binomial distribution if we have in the binomial distribution n here is greater than 50, because in binomial table we only have n less than equals to 50, and if we also have, when we times n and p, we get greater equals to 5, we can also use normal approximation, but the p must be between 0.1 and 0.9. Okay, so the most important thing is, if we have n greater than 50 in binomial, we can use normal approximation. But then, since we have in normal, we have mean. Okay, this one, if you remember from previous video, and p is, normal is we have mean and variance. So, to get the mean and variance from the binomial, mean is n times p. Variance is n times p times q, where q equals to 1 minus p. But then, the most important thing in binomial normal approximation is continuity correction. Because we have here, binomial is discrete, but then normal is continuous. So, to change from binomial to normal, or from discrete to continuous, we need to do continuity correction. So, what is continuity correction? For example, if we have, okay, this one is binomial, binomial is discrete. If we have p, x, probability x equals to a, for example, I choose probability x equals to 4. So, to do continuity correction, so this one is continuity correction, okay, to change from discrete to continuous, or from binomial to normal, continuity correction. Okay, or simply CC. Okay, so we will choose 0.5 less and 0.5 more than the value. So, for example, we have probability x equals to 4. So, to change it to normal, we will have probability x between 3.5 and 4.5. Okay, so this one is CC. We don't take the value straight away from the binomial. We need to do continuity correction, because normal is continuous. Okay, so for example, if we have probability x greater equals to a, or probability x greater equals to 4, okay, so if you want to change to normal, we will take the probability x greater than 3.5. Okay, so if we can see here, for example, this one is 4. So, we want greater equals to 4. So, if you want to do CC, this one is CC. So, we will take less than, or 0.5 outside the blue line. Okay, that's why we need to minus 0.5. Okay, next, if we have probability x less than equals to 4. Okay, so we have here x less than equals to 4. And if you want to do CC, we will take 0.5 outside the blue line. So, that means we need to plus 0.5. So, for normal, after we do CC, we will get x less than 4.5. Okay, so the CC, the continuity correction, we will take outside the blue line. So, for example, we have probability x between a and b. So, if I change it to a number, I take x between 4 and 6. Okay, so what we'll get after we do continuity correction is, we will have 3.5 and 6.5. Okay, so as we can see from this number line, okay, this one, for example, this one is 4, this one is 6. So, we only want between 4 and 6. But then, for CC, we will take less than 0.5 from 4, okay, outside the blue line. And more than 0.5 from 6, okay, outside the blue line. So, that's why we have 3.5 and 6.5. So, that is for continuity correction. The most important step to change binomial to normal, or to approximate using normal distribution. So this is the tips to remember continuity correction. Okay, as we can see from this picture, we have a very big person and a very small thin person. So assuming this one is the normal, okay, so if we have more, okay, or greater equal, for example, we have probability x greater equals to 4. So to do CC, we need to, okay, if you can see from this photo, more weight, eat less. So more than 4, so we need to less. So that means we have to less 0.5. So x less than greater than 3.5. So we need to minus 0.5. So if we have less weight, okay, so we need to eat more, or we need to add 0.5. So for example, we have probability x greater equals less than equals to 4. So to do CC, we need to eat more. So eat more, so plus 0.5. So x less than 4.5. But then you need to remember to use these tips, or these tips, you need to change all sign to greater equal or less than equal. You need to have less than equal, greater equal. You cannot have greater or less than only. Then you can use these tips. Okay, so let's look at example 22. If x is binomially distributed with n equals to 80 and p equals to 0.3, use the normal distribution to approximate the binomial distribution for x equals to 14. Okay, so first, we need to look at the binomial distribution. We have n equals to 80, p equals to 0.3. If we want to use the normal distribution, we can see here, yes, we can use normal distribution because we have n greater than 50. We cannot have value n greater than 50 because binomial table only give value n until 50 only. So here we have 80, so we cannot have the binomial table. Okay, then the first step is to change to normal distribution. So x is normal distribution. So we know that from normal, we will have mean. Okay, this one is normal. We have mean and variance. Then to find mean is n times p. To find variance, n times p times q. So we need to times 80 and 0.3 to find the mean. And we have to times 80 n times p times q. Okay, so this one is the value q lah. Q, or 1 minus p. Then we will have the normal distribution, 24 as mean, 16.8 as variance. So this one is mean, this one is variance. Okay, so that is the first step. So the second step is to do continuity correction. So here we have x equals to 14. So if we have x equals to 14, if you want to do CC, we will take outside the blue dot. So we will have probability x between 13.5 and 14.5. Okay, so we take outside the blue dot. So we have to minus 0.5 and plus 0.5 here. Next, this one, the second step is normal. So next, we will solve normal distribution by standardizing it by changing x to z by using this formula, x minus mean over standard deviation. So probability 13.5 minus 24 over z 16.8, z 14.5 minus mean over standard deviation, we have 16.8, set 16.8. Okay, then we have probability z between negative 2.56 and negative 2.32. Okay, next we will solve this normal. So draw a bell-shaped curve. So this one is the bell-shaped curve. Okay, we have the both sign are negative, so this one is 0, this one is negative 2.32, and we have negative 2.56 here, so this is the area. So if you want to use the statistical table, normal table, we need to change it to positive. So change it to the positive side, so we'll get this one is negative 2.32, we change it to 2.32 positive, and then we have negative 2.65, it will become positive 2.65, and again the area is just the same. Okay, so that means we will change it to, okay, so just remember what you have learned in previous video, normal distribution, 2.3 minus 2.56, or probability Z greater than 2.32 minus probability Z greater than 2.56. Why we need to change it to a greater sign? Because normal table only give greater sign or greater equal sign. Okay, then we will check this value from normal table, page 21. So 2.32, 2.3. So this row 2.32. So this column. So where is 2.32? This one. 0.0102. Okay, so just write the value 0.0102 minus again 2.56. Okay, so we will use different color, 2.5 and the value 6. Okay, so 0.6, look at the first row, the uppermost row, so 0.6. So what is the value we get here? 0.00523 minus 0.00523, and solve this, we'll get 0.00497. Okay, so let's revise again the steps to solve this question. So the first one, we need to change from binomial to normal. Okay, so this is the first step, change binomial to normal by using this formula, NP and PQ. Next, since we have this one is normal distribution, so we need to do continuity correction. So the second step is continuity correction. Okay, so we have x equals to 14. So we need to take 0.5 less and 0.5 more. So we have x between 13.5 and 14.5. Then the third step is to change it to z and solve normal. So use this formula, this one, to standardize it and solve the normal distribution. And then just solve like you solve normal distribution. But then don't forget to do continuity correction. Example B, we have probability x greater than 15. So since we have find the normal distribution, we have x normally distributed with mean 24, variance 16.8. Okay, please refer the first example we did just now. So this is our first step. We change it to normal distribution. So the second step is to do CC. So here we have probability x greater than 15. So we have, okay, draw number line. If you're not sure, just draw number line. So x greater than 15. Okay, so if you want to do CC, we will take 0.5 outside the blue line. So that means you need to minus 0.5. Okay, with condition, this one must be greater equal. So if you do CC, we have probability x greater than 15 minus 0.5, so we get 14.5. The next step is to standardize it, change it to z with the formula we used just now. So probability z less than 14.5 minus 24 over cert 16.8. So we get probability z greater than negative 2.32. Okay, so this one is better. So we have negative 2.32. So this one is 0. Remember, this one is 0. So negative 2.32 greater than. So this is our area. So change it to positive because we only have positive value in normal table. So negative 2.32 we have, so 2.32 positive. And this one is the area. So that means z greater than 2.32 is equals to probability z less than 2.32. But then remember, table only give probability z greater. So this is from table normal. So that means we need to change z less than 2.32 to 1 minus probability z greater than 2.32. And why is that so? So we have 1. 1 is the total probability. Okay, so this one minus, so we don't want this area. So, and this area we can get from table. So that's why we have 1 minus probability z greater than 2.32. Then look at the table. Okay, 2.32, I think we already have it. So 2.32 is equals to 0.0102. So 1 minus 0.0102, and then we'll get 0.9898. Okay, moving to question C. Probability x less than 16. Okay, so look at the sign. We have less than, but then if we want to do CC, it is better if we change the less sign to less than equal. So it will be probability x less than equals to 15. Okay, because here we have 15, then we have 16. You want less than 16 but not including 16, so that means you need from 15 and below. Okay, so this is the first step. Sorry, this is not the first step. We just change less than sign to less than equal. Then we use the normal distribution we get from previous example. So we have x normal distribution with 24 and 16.8 as the mean and variance. So this is the first step again. Then the second step is to do CC. So since we want to do CC, we have less than equals to 15. So outside the blue line, so we need to plus plus 0.5. So that means if we do CC here, we have probability x less than, I think I should change it to blue. Probability x less than, so 14.5 or 15.5. Yes, 15.5 because we need to add 0.5. Then the third step, can you remember the third step? Yes, to standardize it, so we change it to z. So 15.5 minus mean over standard deviation. Don't forget to insert 16.8 because 16.8 is variance, but then in this formula we need standard deviation. So we have probability z less than negative 2.07. And again, okay, if you're not sure, just draw the bell-shaped curve. Okay, so we have, my bad. So this is the bell-shaped curve, 0, negative 2.07, less than. So if you're not sure how to draw or to shade the region, look at this sign. This sign shows the region to the left. Okay, assuming that is an arrow showing the left side. So from left of negative 2.07, this one. So this is the area. Change it to positive because normal only give positive. Again, my bad. Okay, so negative 2.07, so 2.07, and then just look at the area. You can just estimate the area. Where is the area, so that the region will be the same. So almost similar, right? That means probability Z less than negative 2.07 is equals to probability Z greater than 2.07. And why we need to change it to positive? Because table only give value greater or greater equal. It's just the same for normal. Then look at the normal table, 2.07. Okay, so let's change to purple. 2.07, 2.07. So where is 7? This one. Okay, so can you find the value? Yes, the value is 0.0192. So equals 0.0192. Okay, this one is straight away from the table. You don't need to 1 minus anything. Okay. Next example, x between 13 and 29, but then 29 inclusive, 13 inclusive, 29 not inclusive. So, we need to change it to equal sign first. So, x between 13 and 29, 13 inclusive, so we have 13 x, and so what do you think for this value? 28 or 30? Yes, 28, because we don't want, the maximum is 29, but then we don't need 29. So what is before 29? 28. Okay, so change it to equal sign. And again, this is not CC. Okay, so we have normal. We already calculated from previous example. So x is normally distributed with mean 24, variance 16.8. Okay, so this one is the first step. Then the second step is to do CC. So now we are going to do CC. So draw number line. If not sure, draw number line. There's no harm if you draw the number line. So we have 13 and 28, both inclusive. So to do CC, just outside the blue line. Okay, so negative 0.5 and positive 0.5. So CC is 12.5. Okay, please be careful when you add or minus 0.5 here. So x 28.5. Then what is the third step? Yes, to change it to z again. Okay, you already did 3 example up there. So this is your 4th example. You should know by now. So what is the formula? X minus mean over standard deviation. So 12.5 minus 24 over Z 16.8. Z 28.5 minus 24 over Z 16.8. So that we have Z is between negative 2.81 and 1.1. Okay, so again, if you're not sure, just draw the bell-shaped curve. Okay, so this is our bell-shaped curve. Sorry, I changed it to blue. I think I like blue better. So this one is our bell shape. So we have negative 2.8. Again, this one is 0, so negative 2.8 somewhere here, the negative part, and the positive part 1.1. Okay, so what we can do is 1 minus, so we don't want this one, we don't want this area, and this area is z greater than 1.1. So 1 minus probability z greater than 1.1, and we also don't want this one. So what is the area? This one is probability z less than 2.81. Why less than? Because this area, the red area, is on the left of line 2.81. Sorry, negative. I forgot the negative, so I write it again. Negative 2.81. Then if you want to use the normal table, we need to change this negative to positive. So we can simply just change less than to greater, negative 2.81 to positive 2.81. So z greater than 2.81. And now we will use the table 1.1 and 2.81. So okay, different color, I think orange. 1.1. We find the 1.1 first. So 1.1, 0. So what is the value? 0.1357. 1 minus 0.1357 minus z greater than 2.81. So let's look at the table again. 2.81. 2.81. So 1 here lah. Here. So where's our 2.8? So what is the value? 0.00248. So minus 0.00248. Then we'll get the answer 0.86182. Okay, so that is how we want to change from binomial to normal by using normal approximation. So again, the steps you need to remember. You need to find mean and variance from here. NP and PQ, the formula. Then CC. So before you do CC, make sure the symbol is less than, equal, or greater than equal. You need to have the equal sign. And the third step is to solve normal by standardizing it, by changing it to Z. By using the formula X minus mean over sigma. So that is example 22. Let's look at example 23. Analysis of records over a long period reveals that 5% of the scholarship holders will break their bonds before their term of service expires. Question A. What is the probability that in a random sample of 8 scholarship holders, exactly 2 of them will break their bonds? Okay, so before we solve this question, we need to understand this question first. So we have X is equals to the number of scholarship holders will break their bonds. Okay, so now we are dealing with number of people, okay, or in bahasa Melayu pemegang beasiswa. So of course a person, a people. So if we are using binomial, so it is suitable to use binomial because this is a discrete random variable. Okay, now so X is binomially distributed with n. Remember, if we want to use binomial, we need to have n and p. So the number of trials, or the number of sample, which is 8. Okay, we have a random sample of 8, so n is 8, and the probability is 0.05. So 0.05. Okay, the number of scholarship holders that will break their bonds. Okay, what is the probability? Exactly 2. So we need to find X equals to 2. Okay, so for this question, we don't need to approximate to normal because we have n equals to 8. Our n is small, and we can simply use binomial table or the formula. Okay, so for this question, we use binomial formula. So n C2 times 0.05 to the power of 2 times 0.95 to the power of 6. Okay, so remember this formula from video 2, binomial distribution, and Cx times p to the power of x times q to the power of n minus x, binomial. So just calculate this value, then we'll get 0.0515. Okay, again, this is not normal approximation because we have n equals to 8. To use normal approximation, we need to have n greater than 50. Okay, question B. Find the minimum number of scholarship holders that should be sampled if there is to be a probability of more than 0.95 that at least one scholarship holder will break their bond. So, minimum number of scholarship, that means n, we don't have n, and this is what we need to find. And probability, still the same, because for binomial, probability is just the same. Okay, at least one scholarship holder. So, this one is X, okay, as we have defined, X is number of scholarship. So, probability X at least 1. So, what is the probability? The probability. So, this one 0.95 is probability. Probability more than 0.95. So, more 0.95. Okay. But then, we cannot straight away use table because we don't know exactly what is n. So what we need to do now, we need to change greater than 1. We change it to 1 minus probability x equals to 0. So why we change this one to this one? Okay, so again, just use number line. So for example, we have 0, 1, 2, 3 and so on. We want from 1, 2, 3, 4 and above. We don't know what is the n. Then we don't want 0. Okay, so 1, the total probability, total prob equals to 1 minus what we don't want. So we don't want probability x equals to 0. Okay, so that's why we have 1 minus probability x equals to 0 less than 0.95. Okay, so rearrange, we'll get probability x equals to 0 greater than negative 0.05. But then, we don't want to deal with negative, so we just change it to less than 0.05. Greater, less than, negative, positive. Okay, since we have equal, if we have equal, we can use straight away use formula. So the same formula we use in question A, NC0 times P 0.05 to the power of 0 times Q 0.95 to the power of n minus 0 less than 0.05. Okay, this one will be 0. Any number C0 will get 1. 0.05 to the power of 0 equals to 1. So what we have left is 0.95 to the power of n less than 0.05. Then log both sides so that we can have n. So n log 0.95 less than log 0.05. Then simplify, n greater than log 0.05 over log 0.95. Okay, please notice here we have less than, but then when we rearrange this one to right hand side, we change it to greater. Why is that? Because this one, if we press calculator, we'll get this one is negative and this one also negative. So to omit the negative, we need to change the sign from less than to greater than. N greater than 58.4. So what is n? N equals to 59. Okay, why is 59? Okay, so 58, 59, so 58.4 is somewhere here. So greater than 58.4. So what is the integer? 59. So that's why n is 59. Okay, so the last example. In the same year, the government awarded 300 scholarship. Find using a suitable approximation the probability that between 15 and 20 scholarship holders will break their bonds. Okay, so again, this one, since we have defined x as number of scholarship, so that means we can again use binomial distribution with n equals to 30. So now our n is very big, 300. And what is our p? P is 0.05. Then we need to find x between 15 and 20. So x between 15 and 20. And remember, if you have between, n, so we don't have equal sign, just less than. So we will use normal approximation. We change it to normal with NP, so 300 times 0.05, and NPQ, 300 times 0.05 times 0.95. So that we have X is normally distributed with mean 15 and variance 14.25. Okay, so this is our first step. And then the second step, you still remember, we need to do CC, continuity correction. But then before that, we need to change the sign to equal. So we have X is between 16 and 19. Okay, so just draw number life if you're not sure. 15, 16, 17, 18, 19, okay, 20. Okay, X between 15 and 20, but then 15 and 20 does not include it, so we start from 16 and 19 because this one not included. Okay, so that's why we have X between 16 and 19 included. Then the second step, use CC. So if you want to do CC, again remember outside the line, so minus 0.5 here and plus 0.5 here. So when we do CC, we get X between 15.5, sorry, X, still X and 19.5. Then we standardize it, change it to Z, the third step. So probability 15.5 minus mean over standard deviation, so set 14.25, Z 19.5 minus mean over set 14.25. So here we have Z between 0.13 and 1.19. Okay, now draw bell-shaped curve. So this one is 0, 0.13, 1.19. So we want this area. So what we need to do is greater than 0.13, probability Z greater than 0.13 minus, so minus this one, we don't want this one, so greater than 1.19. So let's look at the normal table. 0.13, so 0.1, 0.13. So what is the value? 0.4483. 0.4483 minus probability Z greater than 1.19, so 1.19. So what is the value? 1.170. Okay, 0.1170. 0.1170. So we have the value. The answer is, the probability is 0.3313. So again, let's revise the step. This one we will use normal approximation because we have n. This one is n greater than 50, so we cannot find from binomial table because binomial table only give until 50 only. Then we will use normal approximation with mean n times p and variance n times p times q. So this is the first step, change it to normal. So the second step is to do CC, but then to remember, before you do CC, continuity correction, make sure you have equal sign. So X between 15 and 20, you change it to 16 and 19 both inclusive. Then the third step is to standardize it by using the formula X minus mean over standard deviation. So if you're not sure which area to minus which area, just draw the bell-shaped curve. Okay, so that's all for video 4, And that's all for this semester and this final chapter of your final semester. Thank you, and I wish you all the best for your upcoming exam. Bye.